Hey folks, Serdar here, and in this episode of Dev with Serdar, I'm going to be running down the biggest quirks in Python's datetime library and how to work around those quirks. Now, if you've already worked with Python dates and times, you already know by now that Python has standard library modules for dealing with those kinds of values, chiefly the datetime module. And the first thing you might find confusing about datetime is its namespacing. It's also the name of one of the data types that it provides, which is namespaced as, get this, datetime.datetime. Now this can be deeply confusing, especially to beginners, because if you say import datetime in your code, and then you refer just to datetime later on, it isn't always obvious at a glance if you're talking about datetime the library or datetime the data type. Now, a good code linter or code analyzer would probably be able to give you an answer if you hovered over it with your cursor, but we shouldn't have to do that. It should be obvious at a glance what we're talking about. So there's two ways to avoid this. One of them is to use a slightly different import construction, where we say from datetime import, and then import only the objects from the datetime module that we need into our code. The other approach is inspired by what some people do with the NumPy library. With NumPy, a lot of people will say import NumPy as MP. So what we can do with datetime is say import datetime as DT. And this way, DT refers to the library, and datetime will only ever refer to the data type when we do import it. So this way, you can always see at a glance exactly what's being referred to. The next thing to keep in mind with datetime is time zones. Now, time zones are a bane to anyone who's ever worked with datetime values. They're like dates and times themselves. They're inconsistent and they're illogical. But when you're creating a datetime value, it's always best to create one with some kind of time zone assigned to it by default, just to be on the safe side. See, a datetime value that doesn't have a time zone assigned is called a naive datetime. If you have a naive datetime value and another datetime value with a time zone, you can't use them together in a predictable way. There's no way to tell how to apply one to the other. So to that end, any datetime objects you generate in a program should have some time zone information attached to them, even if you're just using UTC time as a safe fallback. You can always convert UTC-based date times to a local time zone for output, and you can keep the original objects as UTC. Now, the third thing to keep in mind is the behavior of time delta objects when you're dealing with months or years. See, time delta objects are the kinds of objects you get when you take two datetime objects and get the differences between them. The resulting object tells you what the delta or difference is between those two times, and it's calibrated in seconds, minutes, hours, days, and weeks. But it does not have months or years. And no, this isn't a bug. It's because months and years may not be counted as consistently as seconds or days can. Here's an example. Let's say I want to add 1 month to a given date. But what does that mean if 1 month has 30 days and the other month has 31? You see the problem? It's only possible to use seconds or days to get reliable results with a time delta. So any calculations that you make have to revolve around basic time units like seconds or hours, or basic date units like days or weeks. Finally, it is worth considering using another library that replaces datetime. One such library is called Arrow. It's a third-party drop-in replacement for datetime, but it adds a number of other conveniences that datetime does not give you. For instance, you can get the range of a given time unit, like a month, or you can iterate over a time or date range a unit at a time, like a day at a time or an hour at a time. And another thing you can do is you can get the floor or the ceiling of a time range, like the first or last day of a month. It also provides handy ways to work with time zones, and it has functions for humanizing dates and times or making them casually readable. So if Arrow is so great, you're wondering, why not just use it for everything? Well, for one, datetime is a standard library offering, so it's everywhere, it's well understood, it's well supported, even if it does have these kooky quirks we've been talking about. It's also not trivial to move an existing program from datetime to Arrow. So the best place to start using Arrow is in a new project where you don't have any legacy considerations. That said, if you're trying to hand-roll a lot of what Arrow offers you, like working with ranges of times or dates, and those can be tricky, the migration may well be worth it in the long run. So to sum up, be careful of datetime modules namespacing, and construct your imports to avoid confusion on this. Use time zones on datetime objects, even if they're just using UTC as a placeholder. Be careful of how time delta objects don't give you months and years. And consider using Arrow as a datetime replacement if possible because of the conveniences it provides. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.